Hello everyone, my name is Manjunath Venkatra. Welcome to another session of Thought Data. In this session, we are going to learn about how to create a packet mirroring session in Google Cloud environment. In Google Cloud, there is a functionality available where you can actually capture the packet traffic, which is the network traffic, from the machines where you want to monitor, which are your computing instances, and send it to a target instance group, which is a group of computing instances which will receive the traffic. Now for this illustration purpose, we have kept it extremely simple. We have just two instances, as you can see on the screen right here, instance 2 and instance 3. Instance 2 is the machine from where we will actually do the traffic mirroring or the packet mirroring, and we would like to receive the traffic on instance 3. So all the inbound and outbound traffic which is going on instance 2, we would like to send it to our NetSense packet sensor, which is running on a Linux based operating system on the instance 3. Now before you begin with any configuration of packet mirroring, there are a few things to keep in mind in Google Cloud. The first thing is you need what is called as an instance group. So Google Cloud does not allow you to directly send a packet mirroring destination to an individual instance. It expects a instance group. So we're going to create an instance group, and we're going to associate our target instance, which is our virtual machine where NetSense packet sensor is running, to that particular instance group. So before you begin, you have to first create the instance group. The second thing to note is Google also needs what is called as an internal load balancer. An internal load balancer is a function where the traffic from all the source endpoints or the source virtual machines will be delivered to an internal load balancer, and the internal load balancer sends it to an instance group. So additional configuration from Google requires you to create what is called as an internal load balancer. So we're going to take a look at all these aspects in this session today. So right now, first thing what we will do is we have identified the instances. Instance 2 is going to be our source machine, and instance 3 is going to be our destination machine, and we are going to create an instance group first. So what we're going to do is we'll go to instance group. Now before you create an instance group, another requirement is to create what is called as an instance template. An instance template is something which will let the instance group know that if you are associating a certain set of computing instances into the instance group, what kind of a configuration they will have, right? So that's what the instance template will actually do. So let's start with the instance template first, and then we will go into the instance group. So go to the instance template, and you can see that we have created an instance template here. You can click on create instance template, and you can pick and choose the kind of information what you need here. Give a name to the instance template, and you can say what kind of machine configuration will be the machines which will be part of this instance template. When you apply an instance template to an instance group, these are the kinds of machines configurations which will be running in that instance group. So you can pick and choose whatever you would like according to your needs. You can leave everything as defaults, and you can just say create, and it will create an instance template. So right now, as you can see here, we have created an instance template. I'm going to edit this, what we have done, and this instance template is basically running with E2 medium, and basically it has default configurations, right? So rest everything is a default configuration. So so once you have done with the instance template, you can actually go to the instance group, and you can create an instance group, and you can click on instance group right here. You can give a name to an instance group, and you have to select the actual zone in which the instance group will be created. So this is extremely important. Your instance group will be the same region, the US region where your instances are actually located. So you have to make sure that the instance group what you are creating is exactly in the same zone where your instances are actually located. You can leave rest of the things as defaults, and you can create the instance group. So make sure you create the instance group, and once you are done with one another critical thing which I would like to add here is you have to make sure that you are creating an instance group which is unmanaged. So when you are creating the instance group, it will ask you what kind of an instance group you are creating. Make sure that the selection is unmanaged instance group, and you can give a name, and look, the region is going to be the region in which the instances are located, and you can leave the network as default, subnetwork as default. And here is where it will ask you which are all the instances, the VMs, which you want to associate with this instance group. So you have to associate only the target VM where you would like to receive the traffic, which in our case is going to be instance 3. So you will have to only select instance 3 here, and just create the group, right? So that's pretty much it. You can just create the instance group. So make sure you only select the target virtual machine where you would like to receive the traffic, and not the source instance. Okay. Alright, so once your instance group is created, we'll have to now start with what is called as an internal load balancer. So let's start with an internal load balancer. So go to load balancing. You can search for load balancing function in the search option right here. You can see here there is a load balancing service. Go to the load balancing service, and let's start with creating a load balancer. So create a load balancer. So for this packet mirroring function, or the packet function where we are mirroring the traffic, you need a TCP load balancer. So this is an internal load balancer which we are going to create with no external access to any end users outside. So it is not an external facing HTTPS load balancing or a UDP load balancing. It is a TCP internal load balancer. So start the configuration right here, and you can see that I want to create an internal load balancer. You can select here. I want to do it only between my virtual machines, and I want to do it in my single region. Select single region. This will open up the dialog for the internal load balancer. You have to give a name. Say I would like to give a name, internal LB, just an example. And here again, the load balancer should be in the same region as your virtual machines. So our virtual machines are in US Central 1, and we're going to select US Central 1. You can choose the network is the default VPC network, whichever is the default network on which your VMs are located. And there are two more configurations here called as backend configuration and the front-end configuration. So for an internal load balancer, where you would like the packets to be delivered, which is the backend configuration, and what is the front-end configuration. So in the backend configuration, here now you will actually see, you will be asked to select the instance group which you just created. So the instance group which you just created with a destination virtual machine, which happens to be the NetSense packet sensor, the virtual machine which was associated with that instance group is the one which you will select. The exact name what you had given, you select that, and you can actually create a health check. It will also ask for a health check. You can actually add a health check. If you don't have one, you can say create a health check and leave everything to default. Just give a name to it. Leave all the configuration to default, and once it's created, you just select that health check. So once this is done, the backend configuration is completed for the load balancer. Click on the advanced configuration here. There is nothing to do. So now go to the front-end configuration. So in the front-end configuration, you don't need to give any name. The protocol is automatically selected, which is a TCP based load balancer. It will ask for subnet. You will have to choose the subnet in which your instances are running, which happens to be our 10.128.0.0 is the subnet in which our instances are running. Select the subnet, and here you can leave the internal IP address as automatic, which means that Google Cloud is going to automatically allocate an internal IP address to this load balancer on its own. So select the ports as all, and global access is not required because this is an internal load balancer. And here is a very important configuration which you don't see by default. You'll have to expand this advanced configuration. Here is where you will actually see the packet mirroring. So you have to enable packet mirroring for this load balancer. Now this is an extremely important configuration which you don't see by default unless you expand this advanced configuration. If you do not enable this, what will happen is basically when you are actually creating the packet mirroring function, you don't see the load balancer because that load balancer is not associated with packet mirroring. So this is an extremely important configuration. Make sure you enable this. Go to advanced configuration, enable this load balancer for packet mirroring. Done. Once you are done, just create the load balancer. So once you do this, you will see the load balancer here. We already created a load balancer, as you can see here. You can see the load balancer. It takes a few seconds to create it, and you can see all the configuration what it has actually done. So that is basically the load balancer. Now once you do the load balancer, now we can actually start the packet mirroring function, configuration of the packet mirroring. So now you can actually go to packet mirroring. As you can see here, there is you can search for packet mirroring. It's also part of the VPC. You can go on the left hand side pane. You can go into the VPC network right here, and you can see there is an option for packet mirroring. Just launch that. So once you launch that, you have to create a policy for a packet mirroring. You will create a policy. So create the policy, give a name to the policy, select the region again where you would like to apply this packet mirroring policy. It should be the same region where your VMs and your load balancers are all located, and that happens to be our US Central one in our case. And policy enforcement, you would like to enable this policy. So click enable and continue. Choose the network. This is going to be the source network, where you would like to enable the packet mirroring function. So that's going to be your default network. And say continue. Now here is where it will ask you from which source you would like to enable the packet mirroring. So this is an extremely important configuration for packet mirroring. You can pick and choose networks. You can pick and choose individual instances depending on your requirement. Right now we are trying to create a source from a individual VM. So you can select here individual instances, click select. It will show you all the VMs which are there in your Google Cloud platform, and you can pick and choose what you want. So in our use case example here, our source is going to be instance 2. So hence we are going to select only instance 2. Instance 3 is actually our target, so it's not a source. So we are going to only select instance 2. Select and continue. Now here is where it will ask you in the packet mirroring function. Here is where it will ask you what is the destination for this packet mirroring function. Now as I mentioned earlier, it's going to be an L4 internal load balancer which we already created. And if you associated packet mirroring function in the configuration, that load balancer you will see here. This is the name which we had actually given to the load balancer. So you will automatically show up. Now if you are not selected that packet mirroring functionality when you created the load balancer, you won't see that load balancer here. So make sure you have selected that packet mirroring functionality in the load balancer when you created the load balancer, so it shows up here. You can select it and say continue, and you can say mirror all the traffic. You can also optionally pick and choose what kind of traffic you want to mirror. By default we are selecting all traffic. We want all inbound and outbound traffic, and you submit, and that's going to create your packet mirroring function. So once you create the packet mirroring function, as you can see here, we can see here we have already created the packet mirroring function. This is all enabled, and this creates the packet mirroring function. So basically this is the end of the configuration. What this means is basically once this is all done, all the inbound and outbound traffic which is coming to the computing instance, which is the instance 2 in our case, the inbound and outbound traffic will also be sent to instance 3. So if you are running any kind of sensor, which is our Thought Data's NetSense packet sensor, if it is running on the virtual interface of instance 3, it is going to pick up all the traffic from instance 2. So you can actually expand the scope of configuration. You can select n number of instances where you want to mirror the traffic in your Google Cloud platform, and that's the way you actually accomplish a packet mirroring feature in Google Cloud platform. So thanks for watching. If you have any questions, you can always reach out to us on info@thoughtdata.com. You can also reach us on support@thoughtdata.com. If you have any questions about how to set up packet mirroring function in your Google Cloud platform, and our customer support engineers will be happy to help you out. Thanks for watching, and we'll see you in the next session. Thank you so much.